and in today's video, we're gonna go over the science of cooking. Oh, I like this video. Anything about food, I love, bro. It's gonna be one of my favorite. I'm a hungry boy. Hungry. Can someone donate me some beef jerky? Okay, so we're gonna go over the food chemistry fundamentals, and the kitchen is called a scientific laboratory. I don't know who calls that, but so macromolecules. So proteins are long chains of amino acids, and heating them up causes them to denature, which basically means unfold. And coagulation means linking together, transforming liquid eggs into solids. We also have carbohydrates, starches, and sugars that provide structure and sweetness, and they undergo good. Hold on, gelatinization and browning under specific temperature thresholds. So, and we have fats and lipids, which are non-polar molecules that conduct heat-efficient, carry fat-soluble aromatic flavor compounds, and impart tenderness and richness. Wow. You know, when I think about cooking, I just think about cooking steak. I mean, I not to toot my own horn, but I do make a mean instant ramen, bro. Oh, what if instead of instant ramen, it's just quick ramen? You know. Is that the next $1 billion idea? What the? Produced by me? Hold on, let me go on Instagram just for a second. Host. We're not gonna talk about that. Wait, what? Huh. So maybe I should stop scrolling. Alright, so next we can talk about how energy moves with heat transfers. So we're gonna talk about the physics of cooking now. So cooking is the fundamental transfer of thermal energy to alter chemical bonds in physical states. So you have conduction, which are direct molecular contact, like steak searing on a hot cast iron skillet. Oh, I could go for a steak right now. You know, look how beautiful the clouds are. So sunny and like blue. Imagine the sky was orange. Everyone would just think that's normal. And if it was blue, everyone would think it's weird, but it's I don't know. So you have convection, which is fluid or air circulation, like boiling water or air frying. We also have radiation, which is electromagnetic waves, broiling or infrared grilling. So target thresholds, so specific chemical transformations occur at precise thermal milestones, from protein denaturalization at 140 degrees Fahrenheit to flavor browning at over 280. So next we could talk about the deep dive in the Maillard reaction, which is the most important chemical reaction in flavor history. What the is it? That's what is Jerry say? The most important chemical reaction for flavor history? Alright. So this was discovered by Louis Camille Maillard in 1912. So a non-enzymatic chemical reaction between amino acids from proteins and reducing sugars when exposed to dry heat. So around 280 degrees Fahrenheit. So the golden temperature range where the reaction rapidly accelerates. 104 degrees Celsius to 165 degrees Celsius. So this creates hundreds of brand new flavor and aroma compounds, and is responsible for savory, nutty, and complex taste of brown food. Wow. Let's chill. So now, so we're gonna go over Maillard versus caramelization. So the end reaction involves amino acids and reducing sugar, while caramelization is only for sugar. And The M reaction is generally cooler. Its flavor profiles is savory, umami, nutty, meaty, toasted. Well, this is more sweet, bitter, butterscotch, nutty. So classic examples is searing steak, bread crust, coffee beans, and caramelization, caramel sauce, toffee, seared onion, sugar. Yeah. Where's the beef jerky? I kind of want to scroll, bro. Oh. I feel like I haven't been swimming in a while. I don't know. Am I better than Michael Phelps? Wait, let's say Michael Phelps only got to. He has to run in water. Who would win? Who would win? That's a genuine question. Who would win? I think I would win, right? What if? What? No. What if I get to run on the land, but I have to walk on? But I have to handstand walk. This is all really important questions, guys, that needs to be answered. It's like breakthrough. Oh, that looks good. I am not looking at Instagram stories right now, trust me. But okay, the three molecular stages are condensation, where the carbonyl group of a sugar reacts with the amino group of a protein to form a glycosylamide, followed by amidori rearrangement. It's also fragmentation, where sugar molecules break down and dehydrate, which produces dicarbonyl compounds and structured degradation aromas. I'm isovaleraldehyde and pyrazines. There's also polymerization, where large brown nitrogenesis polymers called melanodines are formed, creating the physical golden brown crust and deep flavor. What are we talking about? Now we're gonna talk about the Maillard reaction in daily life. So searing steaks and book. If anyone would like to like send me steaks and burgers, my DMs are open. But I was always a some food. But myoglobin and surface proteins react with sugar to produce savory pyrimidines and pyrimidines. Thus, a fresh baked bread with gluten, amino acids, and starch sugars from the crunchy golden brown crust of sourdough or baguettes, and roasted coffee and chocolate. So raw green coffee beans and cacao pods gain their signature complex aromas strictly through roasting the Maillard reaction. So kitchen hacks. Ho. So this is coming directly from me because I'm a pro chef. So three variables to measure. So moisture. Yeah, moisture. Yeah. You don't want dry chicken. Water caps surface temperature at 212. So always pat meat dry before searing to trigger the Maillard immediately. And if anyone wants to send me a case of beef jerky, so pH balance, so alkaline environments speed up the reaction as well. So adding a pinch of baking soda browns onions 3 times faster. But I feel, I remember saying, like, doesn't it take like hours to caramelize onions? It's actually crazy. Also, surface area. Maximizing pan context, use more brown crust and rich flavor compound creation. So here's a pro shot because I'm a pro chef. If you know. So boiling creates softness, searing creates flavor, and understanding heat and moisture control is what separates an amateur chef from a professional chef like me. Like, I know how to make a juicy ramen, even though there's already soup there. Oh yeah, I remember I have ramen in the fridge that I have not cooked yet. But like, I don't know. Hold on, I'm trying to play with this tape measure. Yo, why did it work before? Why is it not working anymore? Maybe I gotta go like this. Yeah, I don't know what. Alright. So, any questions? Key takeaways: cooking is applying molecular biology and organic chemistry, and by mastering temperature, moisture, and amino acid interactions, you will master flavor itself. Like me, they call me Mr. Flavor because my ramen has so much flavor. But yeah, if you know, you know. But that concludes the end of this video, and I hope you can cook instant ramen better today, and I hope you have a good day. I'll see you in the next video. Bye.